From the Oregon State University Extension Service, this is Pollination, a podcast that tells the stories of researchers, land managers, and concerned citizens making bold strides to improve the health of pollinators. I'm your host, Dr. Adoni Melathopoulos, Assistant Professor in Pollinator Health in the Department of Horticulture.
If you're a beekeeper in the Pacific Northwest, you're probably just starting to take your honey off, your honey crop off, and you're digging down into your brood nest, crossing your fingers that you have low levels of Varroa mites. And if you are not a beekeeper, you no doubt have heard about this mite pest. It is the single largest pest of honeybees in the United States, Canada, but in many other countries around the world. Now, the management of this mite, and you have to manage this mite, otherwise the colonies will collapse, has largely been done with acaricides, some of them natural acaricides, some of them synthetic, but all the same, it has been a challenge to manage these mites. And the holy grail that's always been held out is the possibility of bees that are resistant to Varroa mites. Now, there's been a number of efforts towards finding resistant stocks, and one of the most promising has been associated with a trait known as Varroa-sensitive hygiene. And on this episode, I am really pleased to talk with Dr. Thomas O'Shea Weller. Now, Dr. O'Shea Weller is a research fellow based at the University of Exeter in the United Kingdom. But before that, he was at Louisiana State University working closely in collaboration with the U.S. Department of Agriculture on their POL line. This is a line that exhibits high levels of Varroa-sensitive hygiene and has been combined with some commercially important traits for beekeeping. Now, I had known about the POL line, but I didn't know about this research. This is remarkable research involving hundreds of colonies and tracking them over time. And it has some amazing details that you probably haven't heard anywhere else. It's kind of like a first glance. And the reason this first glance is even possible is because it was recorded on the way to the airport from Lethbridge to Calgary, Alberta. Thomas wasn't driving, but Renata from the Tech Transfer Program, the Alberta Beekeeping Commission, was. And thank you, Renata, for taking us safely all the way back and allowing us to record this episode. So without further ado, let's learn about the POL line and the prospect of Varroa mite resistant bees in our time this week on Pollination.
Well, hi, Thomas. Welcome to Pollination.
It's a pleasure to be here.
Where are we right now?
We are in the rolling plains of Alberta, Canada.
Renata from the Alberta Tech Transfer Team is driving us, and we are headed to Calgary from the Southern Alberta Beekeepers Association meeting, where you gave a couple talks. It was a great meeting, eh?
Yeah, it was a lot of fun.
Yeah, we lots of great talks. We got to hear about canola pollination, and you came up from the UK to give two talks, and one of your talks was on bees that are resistant to Varroa. Can you tell us a little bit about, the specific Varroa resistance that you were talking about?
Yeah, so the particular bees that I was talking about were a stock known as POL line, which was at the time at least an experimental stock, and
POL line? Like, how do you spell that?
That's POL and then
what does that stand for?
hyphen line, and it stands for pollinator line, as in genetic line, combined together in a hilarious pun.
Okay, all right, keep going.
So the thing about these bees really is that there's a twofold aim from the breeding program, was to start with Varroa-sensitive hygiene, so a trait where the bees will remove infested brood cells with Varroa to keep mite levels low, and then start to outcross that with very productive commercial Italian colonies over many years. Because one of the problems that we face in honeybee breeding is that when you're selecting for Varroa resistance, it's hard to balance Varroa resistant bees with very productive bees that will be good for beekeeping and work in the industry.
Right. I remember in the early days of Varroa sensitive hygiene, people always complain that, they don't have a lot of Varroa, but they're just not, great for beekeeping.
Yeah, and that was something that came up, especially a year or two ago in the earlier stages of this, when I was giving some initial talks about what we were doing, and I'd often get audience questions saying, yeah, but VSH, they're not they're not very, very productive. And so it's almost a nice segue into saying, well, this is where we're going with this, is to produce something that solves that issue, because we know VSH works. So all we really needed was that other piece of the puzzle, which was productivity. I say all we really needed. It takes years and years of breeding to achieve that.
Well, that's good. Okay, so VSH, because people have heard of VSH, and what's the difference between that and the POL line? The POL line has VSH in it, but it is, it's a good beekeeping stock.
Yeah, so what we did to, I suppose, produce POL line is we took pure VSH bees, and then we took very productive bees, and we crossed them, and then we conducted year after year with very large numbers of colonies. We left them out with no treatment, and then come back at the end of the season and then select only the colonies that have both low Varroa levels and high population sizes and good honey production. And then you repeat this process, and eventually you end up with something that kind of delivers on both fronts.
Okay, great. Okay, so this line is produced, and tell us a little bit about how, still, I imagine getting to that point, going through the work of developing a stock. For a beekeeper, that's fine, but they want to be able to see that this is going to have durable Varroa mite resistance and, good survival and good qualities. Tell us a little bit about the experiment you were describing to see if this was, in fact, the case, to give the beekeeper some confidence in the POL line stock.
Right, so to do that, we had a very large-scale field study in the United States, which was spread across several different regions, South region with Louisiana and Mississippi, and then the Dakotas up in the north, and then also California, where there's a lot of almond pollination going on. And what we did was we took around 720 colonies.
Wait a second, you took 720 colonies?
Well, obviously not me personally, but
it's a lot of bees.
It is a lot of bees, and it was a lot of work, a lot of logistics. I think I should mention now, this was only really possible because of both being able to work with the USDA, they have a lot of resources, and also having really good collaborators in the beekeeping industry who already had the sort of logistics pipelines for these kind of large-scale projects to work. So that really facilitated us to be able to conduct the experiment.
Okay, so you had these 720 colonies, and what did you do? How did you manipulate the genetics?
So the split for the colonies was that half of them were these POL line bees, the ones we wanted to try out, and the other half we took standard industry Italian colonies that was sort of the best available standard that they would usually use, because we really needed to compare the performance of POL lines to what the current best option is to see whether we're delivering an improvement or not. And the way we did it was we split half and half in terms of that, and then within each of those two stocks, for half of the colonies we gave them a normal levels of mite treatment, so 2 treatments. And then the other half of the colonies, they only received initial treatment to stabilize mite levels, and then they were just left to their own devices to face the absolute worst Varroa scenario that we could imagine.
Okay, so am I getting this right? There's 4 groups. You split them in half. Half get this really good Italian commercial stock, half get the POL line, and then within those 2 halves, some got treatment, regular treatment, and others didn't. Is that correct?
Correct.
Okay, all right. And so that allows you to sort of see the effect of not having the treatments, because I imagine that's what a beekeeper really wants to see with a line like this, is if you didn't treat, or if you treated minimally, you wouldn't have, your Varroa mite levels wouldn't get up high, your colonies wouldn't die, and things like that.
Yeah, so there was a kind of twofold goal on this. The first one is, as you said, seeing really to put them to the test. First of all, what is going to happen? Are they going to have reasonable rates of survival? And secondly, how do the commercial colonies respond in that same scenario? Because you kind of need to show that it's a bad scenario normally, but it's fine for POL line, if you're going to actually say anything. But the other part of it was the reason we had the treated colonies as well is because we know in reality that beekeepers are probably going to treat regardless, So we were also interested in, is there an advantage if you're just operating as usual and you're having POL line bees versus commercial bees? Do they still provide some advantage even if you're treating both of them? or is it only an advantage if you're not treating?
Okay, so tell us, how did the Varroa mite look in this experiment? Did in fact the POL line have lower Varroa mites over the season than the untreated Italian colonies?
Yeah, so it was quite a stark finding in the end. What really happened was that it was pretty bad in terms of Varroa, which makes sense because we had all these untreated colonies for a large part of the experiment. But for the commercial Italian colonies that weren't treated, Varroa levels basically exploded. And so by the end of the winter, really, there was less than 30% survival, I think, in the low 20s. And then for the POL line colonies, they did a lot better and achieved up to around 60% survival. So really it was, in terms of performance, the POL line colonies had more than double the rate of survival of the commercial Italian colonies. So it was a really nice contrast in that respect.
Well, for our listeners in Alberta, we are just driving through the Tana Claire's home, which is it's looking good today. Anyways, back to the okay, but back to the episode. So you had a really wonderful graph. It was nice. The graph had each colony and the Varroa mite levels, and then the colonies that died in the winter, they had a red line, and you could just see in the regular Italian stock that was untreated that just like there was this sad, September, October, November, December period where they all just turned red. But there were very few. There were some colonies that had died in the POL line, but it was a lot smaller.
Yeah,
it looked like just like 4 or 5 or something out of that big pool.
Yeah, what happened? I think a few of the POL line ones did end up getting higher Varroa, and that killed them. But yeah, the situation was you'd look at it and think, okay, well that's sort of manageable with the POL line, whereas with the commercial, it was just total decimation, unfortunately.
Okay. So the other thing that I was notable, because people often talk about viruses, that you track it was really remarkable. You track the viruses, a whole range of viruses, I believe, across time, various periods. What did you find there?
Well, I suppose the key finding, which wasn't really that surprising given the Varroa situation, was that for the most part, for the key Varroa transmitted viruses, so especially deformed wing virus A and deformed wing virus B, POL line colonies kept fairly consistently lower levels of viral titer in their colonies than did the commercial colonies. And that makes sense because lower Varroa transmitted viruses sort of follows on from that. But then we also looked at some viruses that were less coupled to Varroa, like black queen cell virus. And actually, it was interesting almost as a control to see that there wasn't any difference between the two stocks for black queen cell virus, which again makes sense because that's not dependent on Varroa.
That's okay. I think that's a really interesting finding, and just so that I understand. So people have heard in the past that some viruses are really strongly associated with Varroa levels that are really strongly correlated. There's likely a strong causal relationship between the two. Deformed wing cell virus is one of them. When you have a lot of Varroa mites, virus levels go up. But some viruses are really not related with Varroa, like black queen cell virus. They're not associated when people correlate the two things together. And there you saw the black queen cell virus kind of cycle independent of the stocks, which really kind of, not paradoxically, but is a really great indication that, that this line is really going to not only have that double benefit of potentially keeping Varroa mite levels down, but those viruses associated with Varroa mite will also seem to be lower.
Yeah, exactly.
Okay, the big question everybody has now, this is great. I imagine, you can, it sounds like what I'm getting from this is that you could have POL line bees. And if you, I guess this is a harsh experiment, but if you didn't have treatment, your colonies would have higher survival. But I imagine most people would still treat.
Yeah, I can't think of that many, especially commercial beekeepers that would do that, not treat when they just do it anyway, and they can, there's no reason not to for them.
Okay, so they may, but they've got an added assurance level, or they may treat less frequently.
Oh, Sorry, I think the thing just dropped off. Okay, I'll just check it's plugged in. So yeah, it is.
Okay. We are at the Claresholm gas station right now, by the way.
All the sites.
It is. I've stopped at this gas station many a times. It's a great gas station. The Shell station has good sandwiches inside if you're on a long road trip up in Alberta, which we are. But anyways, coming back to it. So we've got these. So we have. You may use a couple treatments, but I guess what beekeepers want to know is, I've got now at this insurance level. I might be able to cut my treatments down. This is probably research that still yet needs to be done. But if I do that, am I going to still get the performance out of my stock in terms of honey production, in terms of brood buildup? And I noticed, maybe that's work that's still underway and analyzing that data. But what can you say about performance of these stocks?
Yeah, some of this work has been done, but hasn't really been published yet. But there's been some more recent trials where they took a derivative stock, Hilo bees, which are the sort of commercial offshoot in terms of the breeding program from pole line bees, so the genetics are really the same. They took Hilo bees in North Dakota and they compared them to Carnolian Italian crosses, which again were like the best performing standard bees that they could find for that particular region. And what they did was they treated for mites the Carnolian Italian cross bees, and then they didn't treat the Hilo bees at all, and then they compared the performance from that.
Oh, really? Oh, that's a stringent test.
Yes, yeah. And they found that the Hilo bees actually still outperformed the treated.
Really?
And in fact, I should note that in our own experiment, we saw the same thing. The survival rate of the untreated pole line was equivalent to that of the treated commercial. So the thing we like to say was that the added genetic benefit of the Varroa removal of the stock was equivalent actually to that of a chemical mite treatment of amatraz in this case.
Wow, that's remarkable. Okay, so this sounds like a great stock. Maybe just the last question I wanted to ask is, you talked a little bit about Hilo, and the Project Apis M has been working with the USDA Baton Rouge Bee Lab to get this stock out to people. Can you tell us a little bit about that program and how it's from what you know? And we'll have to get Project Apis M on an episode to also describe this.
Yeah, and I'm sure they'd be very happy to talk about it. So the Hilo breeding program is really a sort of an effort to take what was initially the sort of experimental stock of pole line and make that commercially available at a large scale for beekeepers. So that occurs in Hawaii near Hilo, hence the name. And that program is involving quite a few breeders, and they're really just making the queens commercially available. And I should probably do a shameless plug and say you can visit their website at hilobees.org for a lot more information.
Oh no, you should be proud of that. That's a good.
I am not financially reimbursed for promoting.
I think it's for me personally, and I have no pony in this horse, but I just think it's a really great model from USDA partnering up with Project Apis M and getting something into the hands of beekeepers. Because it seems like we also in the meeting, I think you had a provocative talk about how the interface between research and what beekeepers' needs are, and for a long time there's been talk of breeding bees for Varroa resistance, and it hasn't materialized. And it seems this was the first time that this is kind of crossed that threshold. I also liked your talk because you embedded videos from Bob Danka, where he was very kind of he wasn't pushing up the stock. He was very, if it doesn't work in a commercial operation, this is useless or something. I can't, to paraphrase.
Yeah. I really like that particular clip because it kind of shows the philosophy behind this program, which was occurring over 2 decades effectively of work. Mm-hmm. And it really was based around producing something that actually delivers, which I think is very valuable.
Okay, well, let's take a quick break. We have a segment that we do with all our guests that I have not told you about, but it's going to be fun, I promise. And it'll take us to the outskirts of Claresholm. Okay, we're back, and we're on the outskirts of Claresholm, going down the number 2 now into Calgary. So with that, I wanted to ask you, do you have any book recommendations? Are there books that you really want our listeners to check out?
Well, I'm not really much of a reader because I'm horribly dyslexic and it takes me forever to read. But the one book that I can always recommend that I really like is The Once and Future King by T.H. White, which is the kind of original King Arthur mythos by T.H. White is a great author, and it's an amazing book because it can combine sort of philosophy, science, and mythology all into one, and definitely worth a read.
Oh, wait a sec. So when was this written? Is this like a 20th century thing?
50s, I believe.
Ah, okay.
Yeah.
And so it's kind of like a recounting of the Arthurian tale?
It is. It's almost hard to describe.
But it's fiction. It's not nonfiction.
No, it's fiction, yeah.
Oh. And that's all you're going to give us?
Yeah, no, I almost was about to say, I don't read books, so I can't really recommend. But I think that's probably the only book I can recommend with good confidence on my part.
Well, listeners, you're in good hands. Okay, so how about go-to tool? What kind of tool do you kind of rely on your day-to-day work?
That's easy. That would be a computer. I think I couldn't really do any of the work that I do without a computer.
Well, I think you sort of in jest or maybe seriously you were pointing out, and I will point out this part of Claire's home is a speed trap. Like it is always, yeah. Okay, anyways, and Renata is taking us so. Listeners, you can barely even. Yeah, there's somebody who just got pulled over. Listeners can barely hear the bumps in the road because we're like Renata is like carefully navigating. It's just amazing. It's
pretty high stakes, interviews. The police are after us, and
yeah, there's gonna be a chase scene at the end. Okay, but so I think you were saying in jest that, or maybe in serious, you're really happiest as a researcher when you have large data sets to analyze, as opposed to my tendency is I like to produce the data, but I don't like to I'm very I'm not in my happy place when I have to analyze it.
Yeah, so I'd say I'm sort of almost the diametric opposite of that. I've been not in my happy place quite a few times in a bee yard in the middle of summer in Louisiana with a lot of stings sticking out of my skin. So yeah, I could say that, I prefer being in a computer.
Are there programs that you find for doing analysis that are essential for you?
Yeah, I really like R just because everyone uses it. It's so flexible. There's always new packages coming out and being updated. The community really is what I think makes it really great. I also quite like using some of the AI tools in Python and Anaconda. So PyTorch is quite a nice one.
What's the name again?
PyTorch.
PyTorch. Because I remember the other thing that you've been working on is invasive Vespa wasps to the UK, and you've been working on AI identification tools.
Yeah, so we've been trying to develop with some colleagues from the Exeter Centre for AI and Data Analysis, although I think I get the name wrong, but it has an acronym that I can't remember. But basically, we've been developing some AI tools for detection of invasive species because we're in a really interesting situation in the UK where Vespa velutina, which is an invasive Asian hornet, not the giant Asian hornet, which is Vespa mandarinia, but this other particular Asian hornet is spread all the way across large swathes of Europe, and it's a concern for beekeepers because they'll hawk outside of the front of hives, so they'll hover and wait for returning bees, and then they'll grab them, usually bite their head off and carry them away. And what happens is, over time, it leads to the bees just ceasing foraging, known as foraging paralysis, and then the colonies can then starve because they're no longer foraging. So this particular species is in France and Spain, but not yet established in the UK, but we get blowover of queens on almost
oh really? So the queens is going to blow over once in a while and you find them in the southern UK? Exactly.
And so far the UK government through DEFRA has had a pretty effective extermination program where they've been able to eradicate all of the colonies as they appear, but it relies on public reports, which are notoriously unreliable, and there's so much that comes in that has to be sifted through. So there's a large burden of work. So we're really just trying to transition to a completely automated system that is also environmentally sustainable in that it's a passive monitoring system, doesn't use any traps.
Oh, great. So you've been using this Torch software to kind of do this learning and develop these automated tools.
Yeah, I mean, I really should give credit here to our colleague Andy Corbett, who is much more experienced than any of us when it comes to data science and AI. And we've been working with him to build a really nice data set and labeling and a system that can rapidly identify these hornets, and while ignoring everything else that isn't a hornet, which is, I think, really almost the most important part of this. We'll, again, shameless self-promotion, but we'll be giving a talk about this for Exeter Data Science Week, which I think is in 2 weeks' time.
Great.
Which I think will be online for anyone who's interested in that.
Oh, here in the Pacific Northwest with the giant Asian hornet, I think everybody is looking for good tools to make sure that we can identify and contain the wasp population. That's great. All right, well, our last question is, do you have a favorite pollinator taxa, group, species?
Yeah, well, I was thinking about this one. Could we say that the ants are a pollinator group? I think we could.
Oh,
you knew this was coming. Let's be honest here.
Okay. All right, you make the pitch for the ants. I'm listening. Right.
Well, I've read a lot about how ants can displace pollinator interactions by harassing the pollinators. But in one of those papers, I read that the native ants in, I think this was in an area of South Africa, maybe is it the Fynbos region where they have all the flowers and things, that they found if they removed the native or excluded the native ants from being able to reach the plants and do anything, that actually decreased pollination efficacy or success, which suggests that tangentially the ants, at least in this case, were doing something, which I think gives me the right to pick ants as the chosen pollinators and shoehorn them in. So
I have to say it was a lot of fun walking down Lethbridge with Thomas, because every time an ant appeared on the sidewalk, we'd all stop, and it just drew my attention to this diversity that's on every city block and everywhere.
Yeah, it's a very unhealthy habit, but I do enjoy it.
Well, thanks for joining us on this episode, and have a good flight this evening.
Well, it's been a pleasure, and hopefully the wind is less intense than it was on the way in on the landing.
Absolutely.
Thank you so much for listening. The show is produced by Quinn, Sin, and Neil, who's a student here at OSU in the New Media Communications program, and the show wouldn't even be possible without the support of the Oregon Legislature, the Foundation for Food and Agricultural Research, and Western SARE. Show notes with links mentioned on each episode are available on the website, which is at pollinationpodcast.oregonstate.edu. I also love hearing from you, and there's several ways to connect with me. The first one is you can visit the website and leave an episode-specific comment. You can suggest a future guest or topic, or ask a question that could be featured in a future episode. But you can do the same things on Twitter, Instagram, or Facebook by visiting the Oregon Bee Project. Thanks so much for listening, and see you next week.